Hello and welcome back to Fairhurst Racing. This is the first episode of a series that we thought we'd try out. It's going to be a longer form video, just having a chat, unedited, about what we're doing currently with everything, every project really. Specifically this week on our Big Bloc Chevy build, you'll see engine building, chats about why we're making the decisions that we're making, and other stuff about the dragster as well. We're not quite sure on a name just yet for the series, but I'm sure we'll think of one. So yeah, sit back, relax, and just enjoy the video.
Between us, we're building a Big Bloc Chevy engine. It's basically a 454 cubic inch engine, later model, but it's still a Mark IV, so that would have been in production till about 1990. We are building it old school is the best way of describing it, because it's a stock block. We've stretched that out as far as we can with the stroker kit. It's now 496 cubic inches, so it's got a 4¼ inch stroker scat crankshaft in it, and it's been overboard to 60 thou over, so that's where we come up with the 496, and that's a recipe that was used for years, well before the advent of aftermarket blocks and what you'd like to call mountain motors. Like always with these projects, we're building it for fun. It's for a fast street car, if you want to call it that, best way of describing it. But we want to use the sort of processes and procedures that we used, way back over the years, and it's been worthwhile to point out a little bit of that history, why it's so important to build our engines that way. One of the people we're actually using his tips from is a guy called David Vizard. This book was published in 1970, and at the age of 12, it's one of the first books that I read. It really inspired me. It was so full of interesting stuff as a kid I'd never even dreamt of, and it inspired me to become an engineer. The reason why I'm telling you this is that David is quite senior in his years now, but he has more recently published another book on Big Bloc Chevys. Now, this guy is a world-renowned author. He's moved to America and done so much test work, and he actually does his own seminars and stuff. And in one of these latest books he wrote, Budget Big Bloc Chevys, he concentrates on the more traditional style engines, up to about the 500 cubic inch sort of level. And he has got some really useful tips in this book. It's very well written book, very easy to read. The nice thing about it, it's full of technical information, and some of his new thinking, specifically around increasing airflow at low lifts, is something that we're going to incorporate in this engine. And so we'll be using this book, but we're also going to be using some of the other books that are typically used. This one has been around forever. So this is again a book about building Big Bloc Chevys, but using the more traditional methods. We're also drawing on some aspects of this killer engine book. The reason why I say some aspects is that this was specifically written around aftermarket blocks like the big Brodix blocks, high cubic inch engines. So it's not always that relevant, but some of the thinking behind that, we draw upon that and sort of take it with a bit of a pinch of salt when we're building something which is more on the street. So that sort of sets a bit of the scene. But why are we doing it? And I think the whole reason is it makes us smile. There's a lot of enjoyment in building this. It's not about out and out performance. For Sam and I, it's about a journey, and it's about having a project that we can do together. And I think sometimes that gets lost when you talk to people as a hobbyist. and I'm not the only one. We build these engines for fun. They're a lot of enjoyment, and if it isn't about that, then I think it's not the sort of purpose that we're involved in. We're building it for fun. We're building it to learn. So on this particular engine, we're gonna we're building reliability for the street, but we're also going to put a whiff of nitrous on it. Now, I haven't run nitrous since the 1980s, early 1980s. It's a bit of fun, and because nitrous oxide systems have increased in complexity and advanced so much since I last ran them, it's a good excuse for us to get up to date and again, you know, have some fun. But it's not heavy nitrous motor. It's just there to top off a bit of extra horsepower that we can't do naturally aspirated, and some of this video will explain the reasons why. So we're building this as a father and son team, and it's about enjoying it. And while we're here, we really ought to say something about the flavour of the other engines that we built. That Ford Flathead up there, it was about using parts that make you smile. Johnson lifters, Isky cams, you know, early Holly carburetors. If you take the Oldsmobile that we built in this Roadster, you know, the Oldsmobile was the first overhead valve engine that came out along with the Cadillac, well before the Chevy. And it was nice to build an Oldsmobile. Yeah, we put some very traditional looking carburetors on it and a homemade manifold and a supercharger, but internally we used lots of parts from Joe Mondello, who had such a history of racing Oldsmobiles in the 60s. It was an absolute joy to work with him and his company. He's passed now, but his son is carrying on that. But you know, it was a joy to do something as it would have been done back in the 60s, really. You know, there was a flavour for that. The dragster that Sam is currently running, that was a different way of doing things. That was to a recipe that produced enough horsepower for super competition eliminator racing, but it was a recipe that was reliable. These super comp cars have got to be spot on their performance. They've got to be performing within a fraction of a second, and they've got to do it round after round after round. So completely different philosophy, not totally maxed out because you need that reliability, but still got to produce a lot of horsepower. So having sort of set the scene, I'll go into today's problem.
Yeah, so this is our newest Big Bloc. I had some people a bit confused because I posted a picture on the Instagram like this with 4 cylinders, and they thought, what the hell are you doing with an inline 4? No, it's the Big Bloc, it's just turned on its side. It's a V8, don't worry. We have an idea of what car you know, this is going to go in. We don't have anything specific, but we're pointing in the direction, we're planning. But at the moment we're just building the engine. High horsepower, not a race engine, but reliable and strong.
I'll add a little bit to it because in my mind we're building a Dare to be different from the late 50s. I was born in 1959. It'd be really nice if we could find a 1959 classic, loads of fins on the back, all that sort of stuff, but do it as a Dare to be different, if anybody knows that type of car. So this engine has to look quite powerful and different, which is half the battle. We've got a tunnel ram manifold for it, we've got twin carbs for it, so you can guarantee whatever we do, the engine's going to be sticking out the hood or bonnet, whatever you want to call it. The problem that we've got is we're not quite sure how much cam we can get in this engine, because these cylinder heads are good for 0.75 inch of lift, that's 3/4 of an inch of lift. But we don't actually know how much camshaft lift we can fit in, because we have quite high compression pistons. They're a Keith Black design piston with a pop-up on the piston. We can show you that in a little while. But the critical clearance is the piston to valve clearance. And it's very dynamic because the valves get closest to the piston, not at top dead center, but a short while after top dead center for the intake valve, I might add. So as the intake valve opens, the piston's moving down the bore, but the intake valve is actually opening faster than the piston's going down. Right. So it's chasing the piston. And we'll try and demonstrate that. But what we've done, because we don't actually, we obviously, we're looking to buy a cam, and that specification of that cam involves the lift, the duration, and also the profile of that cam, so they all have an effect. So what we've done is we have put a spare dummy camshaft in there at the moment to enable us to get some idea of what's going on. And the camshaft we've chosen is a full race cam, and that cam has 0.8 of an inch lift, in theory, with 1.7 to 1 rocker arms, which is more than the heads can actually handle. But we've mocked it up with a lower ratio rocker arm and a check-in spring. We don't want to be using the real springs because that puts a heck of a lot of force on things. So we put this lightweight check-in spring, and we have set up a dial indicator. And what actually happens is, as we rotate the engine, we set it up as you would do normally, but we put 0 lash on it, so there's no clearance between the rocker tip and the tip of the valve. And this is set up on the base circle, and as you see, as I wind the crankshaft round, the intake valve begins to open, and that intake, 1, 2, 3, 4, 5, 6, 7, that's 0.7 of an inch of lift, just over that. So, and that's probably about as much lift we can have, and it hasn't hit the piston. Now there's a number of ways of actually checking it. You can put plasticine on the piston, but when I tried that, it took virtually all the plasticine away, so we know it's close. Now I'm just winding this piston up. You can see the piston moving up, and you can see the valve coming down. All right, and that's top dead center. As we start going over top dead center, the valve is now chasing the piston. All right, so I'm going to set that at the closest point, and then we're going to use the dial indicator to measure the piston to valve clearance. The blue stuff, which is on where the exhaust valve hits the piston, is actually plasticine, and you can probably make out the impression of the exhaust valve. We'll show you that in a minute. But that exhaust valve, we measure the depth of that with a vernier caliper as a depth gauge, and that at the moment is something like 0.19 inches, which is way more than we actually need. We've got plenty of exhaust valve clearance, but we've got very little intake valve clearance. Right, so this is actually set at the closest point, contact point between the intake valve and the piston. And if you see when I press that, we've got something like 35 thou. A bit more than that, sorry. 38, but anyway, not 40 thou. That should be a minimum really of about 80 thou. So oh, really? Yeah, so what we do know is that with a full lift cam of 0.7 of an inch, we're going to be really close on our piston to valve clearance. Now I'm not that worried about it, because the acceleration ramp on this cam is very steep. The other thing that you can play with is advancing and retarding the cam. And in actual fact, with this cam retarded, the clearance was only 15 thou. So I've actually advanced it something like 5 degrees to get to this. But, you know, I think it's worth us getting the cam that we want. There's 2 other things that we can do if it's too close. We can remachine the pockets in the piston, which means we've got to rebalance all the pistons because we bought them as a balanced assembly. We've also got a 40 thou cylinder head gasket in here for testing purposes. You can always put a thicker gasket in it. Cometic do really, well, quite thick. You've got a full range of gaskets. But then you start losing compression ratio. So if we do have issues, first port of call is advancing the cam a bit. Second port of call is machining the pistons, and then the third port of call really is losing the compression ratio and taking a hit. Or we just play around with the ratio of these rocker arms, and that's what we intend to do. David Vizard is very keen that you use very high ratio rockers to get the valve accelerating off the seat very quickly. That means that you get a lot of area under the curve, if you want to call it that, of lift. You get a lot of airflow initially on these big block Chevys. So we're going to try and adopt that. We'll buy 1.8 to 1 and 1.7 to 1 rocker arms, and we can put the higher ratio rocker arms on the exhaust valve if we want, if it's too much for the intake valve. But at least we've got a starting point. We put ourselves in a more educated position. So what I'm going to do now is I'm going to take the cylinder head off and show you a little bit about what was going on inside the engine for you, just to put it all in perspective.
Yeah, so just while we're doing this, just a reminder, we are changing the cam to get a general idea of what type of cam we can buy new and put in this. Seeing where the valves and the pistons, if they contact, if they're too far apart, you know, we want performance. And I know I said it wasn't a race engine, but we're going to build it like one for the reliability and the power. Why wouldn't you build it to the best of your ability? So yeah, we're doing our best to try and estimate what is the best cam for the engine, and by doing that, it's a lengthy process, but it's probably the best thing to do.
David Vizard typically ran about 10 camshafts on an engine to find the optimum, and he would do numerous dyno pulls. He's actually used that information he generated over about 20 years. They put that in a computer program that people can use. They tested all different types of manufacturers' cams, and they put that in a program that you can pay to use, and it will choose the cam that's best suited to you if you want to go that way.
Also, if you can see in the back, while we take the head off, drag stuff changes. We have a new plate back here. The old one was about this thick at the top, whereas this one's about this thick. Just to protect me, if anything happens to the engine, we were told to do it, so we're gonna do that. Does make it safer. We have had to redo quite a lot. For example, the fuel hatch. Well, we never had a hatch before because the plate just came straight down. But we've got a fuel hatch now that we can flip out. We've replaced the handle on our CO2 canister
because that broke since 1990. I hate to think how many times that cylinder been opened and closed.
Yeah.
But we are doing other things. We had a problem with the tyres spinning in the shift from first to second. So we have a plan to take some timing out of the car at that shift point, and to use a timer so we can actually play with how long we take the timing out and how much timing we take out. And that gives us the same flexibility as a grid system, MSD grid, which we're using in one of the other cars, but without spending £2,000 to do it. So we've come up with a cheap fix to get the same result on that specific problem of tyre spin. So we'll be using that if we have to. So we've done some mods to keep our scrutineer friends happy, and some mods to keep us happy and keep us a little bit safer if we need to stop it from breaking the tyres loose.
To back that, we also have a new pair of slicks to put on before the new season.
Right, we're ready to look inside the engine, show you a little bit about what we were doing with our piston to valve clearance. We had no plasticine on here. We were using a dial indicator, which is one method. The book, if you can't see inside the cylinder head, you're supposed to you set the dial indicator up and then push the valve down every 5 degrees from top dead center to about 30 degrees after top dead center, and do a reading, and that will give you a good approximation of what the piston to valve clearance is. We were looking in the port, so we were able to accurately see where that closest piston was, and then that closest point was. The other way of doing it is to put plasticine, and on the exhaust valve, we put the exhaust valve in, we put plasticine on the top, and you can see the dimple of where the plasticine has been pressed. Now I will show you exactly what you do once you've got that result. So what we've done is put plasticine on the top of the piston. The book says you're supposed to cut that with a knife and peel it off and measure the thickness of it, but to be perfectly honest, if you zero your vernier caliper, stick it through until it contacts the piston and then just set it down, you can see we've got something like 0.19 inches of thickness there. So that's your clearance. We only need 0.1, so we've got 90 thou we can play with, which is a relative lot. You can see if I peel this off, there are no valve reliefs on the exhaust. That thin bit is your quench thickness, which is your thickness of your head gasket, and the deck height, which is how high your piston is at top dead center below the cylinder head. While we're here, it's worth showing you some of the other issues that you have on these smaller diameter bores. I mean, this is a big bore, don't forget, for a 454, because it's now 496, it's 60 thou over. But compared with these these monster engines, you can see that the relatively large intake valve, which sits here, 2.3 inch diameter intake valve, is actually the cylinder, the top of the cylinder actually shrouds the valve. You can imagine it lifting up and down. So what you actually do is machine the top of the block away to about 60 thou above the land of the top ring, the piston ring. So we're going to use this copperhead gasket as a template to machine away and create a better flow path. Otherwise the airflow would be hitting the corner of the block here, and it all gets very messy around here as far as airflow is concerned. So we're going to machine that. Not so critical on the exhaust, but we're going to do it anyway. It's a good idea, because obviously as that piston moves down and your exhaust valve is open, then you've obviously got that notch as well. So we need to sort that out. But in that case, the airflow is coming the other way, so it helps reduce the step in the bore as it works its way around to the cylinder head and then eventually the exhaust port. So lots of modifications to do. So we've still got quite a lot of work to do on the block. We remove all the flashing, anything that's a stress raiser or anything that could break off with use. When we've finished, we coat the whole of the inside of the lifter valley here with a shellac Liptal paint, which gives it a really good finish and it helps oil drain back. We're also going to do some modifications to the way that the oil drains back on the lifter valley, because you don't want oil pouring back into the engine. And also, if you have any valve train failures, debris tends to get on the cam and do a lot of damage. So you want the airflow, but you don't want the oil flow. So we're going to make some standoffs to stop the oil draining back that way. And what we're going to do is increase the oil drain back onto the cam drive. We've got a gear drive here, so we're going to make sure that all the oil drains back and splashes onto this gear drive to keep that lubricated. This has only been done temporary at the moment, and you can see the idler gears don't line up. So we're going to machine the block a little bit to get the idler gears back in line with this. And then we have to go through the whole process of limiting the travel on the cam by making sure that it's effectively just touching what is now a nice aluminium cast timing cover. You can do it with the standard steel timing covers, but they tend to flex too much. So we've gone and purchased a much stronger timing cover to be able to do that. And of course, we've got the added feature on this particular cam drive of having offset dowels, so that we can change the cam timing relatively easily. And that's a real advantage as you're dialing things in there. The other thing I would say about this gear setup that we actually got from Comp Cams is it's got a proper roller bearing, thrust bearing at the back of it, rather than a bronze thrust washer, which is much better for longevity and reliability. So, you know, there's a lot of things that we've designed into this to improve the valve timing, and it will actually make a little bit more noise, which in actual fact makes it sound like it's supercharged, but that's maybe a bit of an added benefit, bit of a boy racer thing there really, but never mind, we're doing that for a bit of fun.
Yeah, so like I said, this is something new that we're trying, a longer, more chatty, in the garage type of video. Yeah, let us know if you've enjoyed it, if you enjoy listening to it. Next year is going to be very, very interesting. So excited to get back in the dragster properly in Super Comp. And obviously it's Christmas, so get festive. We've got things planned. This isn't going to be the only video this month. We've got some fun things to do, and keep an eye out. We might do another one of these as well. If we have something to talk about, we'll talk about it for an hour. Let us know if you like it, and like I said, get festive.